Here's problem 1521. The mat of a trampoline is held by 32 springs, each having a spring constant of 5,000 newtons per meter. A person with a mass of 40 kilograms jumps from a platform 1.93 meters high onto the trampoline. Determine the stretch of each of the springs. So let's say we had a trampoline with a bunch of springs, and then we have a platform, and someone jumps off this platform onto the trampoline. So basically the potential energy of height with the person of mass m gets translated into the potential energy stretched in the 32 springs. So we should have that mgh is equal to 32 times the 1/2 kx squared, the potential energy of each of the springs. Let's solve this for x. So we're going to have x is equal to mgh divided by 16k square root. So that is going to be equal to 40 times 9.8 times 1.93 divided by 16 times 5,000, all this square root, and if we do that, we get 0.0972 meters, or 9.72 centimeters. That's if we don't consider the stretch of the springs themselves as being height for the person to fall, and that's really something we should consider. So to do this better, we need to consider the extra potential energy of falling that extra x. So we have instead mg h plus x is equal to our 32 springs 1/2 kx squared. So we need to solve this for x. So we have mgh plus mgx equals 16 kx squared. Or I could write this as 16 kx squared minus mgx minus mgh equals 0. Alright, so that's 16 times 5,000 x squared minus 40 times 9.8 x minus 40 times 9.8 times 1.93 equals 0. So that's 80,000 x squared minus 392x minus, this will be 756.6 is equal to 0. So what we have ourselves is a quadratic equation where this is A, and this is B, and this is C. And the solution would be x is equal to a negative b plus or minus b squared minus 4ac square root over 2a. So in this case, that's going to be a negative 392 plus or minus 392 squared minus 4 times 80,000 times a negative 756.6, all that square root over 2 times 80,000. So what is that? We have 392 plus or minus 15,565 over 160,000. If I were to add these, what do I get? I get 0.0997 meters. And if I subtract it, I get a negative 0.0948 meters. I'm going to choose the positive value since we're assuming that it's going down as a result of the person hitting the trampoline. If it rebounds, we could store that energy vertically in the, and that would be the negative answer if it were to rebound and come back up. But we're going to choose this positive answer. And so, considering the extra x, the stretch of the springs is 0.0997 meters, or 9.97 centimeters.